This is Pre-Algebra, section 9-6, Slope-Intercept form. My name is Mr. Rupp, and in this video I will show you how to graph linear equations using the slope and y-intercept, and explain the slope-intercept form of a line. By the end of the video, you should be able to verify that a point lies on a line given an equation of that line, and understand the concepts of parallel and perpendicular lines. Let's get started. 9-6 slope-intercept form. Okay, way back in the dawn of time, back when we sat around the old dead tree waiting for lightning to strike so we could cook dinner, we talked about a beast called a proportional linear function. Okay. A proportional linear function could be written, the equation for it could be written thusly: y is equal to kx, where k was called the constant of variation, or the constant of personality. No, proportionality. Wrong genre. Okay. If you look at the graph here, this graph shows y is equal to 3x. So for every x1, y was 3. When x was 2, y was 6. So the constant of proportionality, the constant of variation, was 3. That was the k. This is how you wrote proportional linear functions. And one of the attributes of a proportional linear function is that they all go through the origin. Look here. This one goes right through the origin. All proportional linear functions of this form go right through the origin. They just branch out at different angles. Okay, but they all go through the origin. There's a whole host of lines that don't go through the origin. What about those? Those are called non-proportional. Non-proportional linear functions. Okay? Now, if you look at this, the proportional linear functions are written y is equal to kx. The non-proportional linear functions, not to run into this over here, I'm going to write it down here a little bit, is written y is equal to mx. We just substitute a different type of variable, m for k. But now we've added something else, b. The m here stands for slope. This is the k up here. This too stands for slope. Because if you look over at our line over here, this y is equal to 3x. 3 is the slope. We go over 1 and up 3. Or over 3 and up 3 and over 1, up 3 and over 1. So it's 3 over 1, so the slope is 3. And because it's a non-proportional linear function down here, we have this guy, and he is called the y-intercept. So the slope of a line is how fast it's rising or falling as you move to the right. And the y-intercept is where on the y-axis the line is crossing the graph, where it crosses it at. Well, for y, the proportional linear functions, y is equal to kx, the b is there, it's just plus 0. Because if you look at our graph over here, where does this line cross the y-axis? At 0. So the equation for the line over here would be y is equal to kx plus b, but b is always equal to 0. So we just write y is equal to kx. Let's do an example here to help explain this. We'll do example 1 on page 495. Okay, and it says, state the slope and the y-intercept of the graph of each of these functions. Okay, so here's the first one. y is equal to 2/3 x minus 4. The first thing to note is that this is in the correct format of y is equal to mx plus b. Y is equal to mx plus b. Well, looking at this directly then, what is m? M is equal to 2/3. What is b? Well, b happens to equal -4. The slope and y-intercept is 2/3 of -4. This is the slope, and this is the y-intercept. Okay? Just like that. Let's do another example. Let's do example 2 on page 495. And here we have x plus y is equal to 6. Well, the slope of the line, the slope-intercept form that we want is y is equal to mx plus b. That means that the y is on the left all by itself, and everything else is over to the right. Well, our equation here, x is over on the same side as the y, so we need to get the y all by himself. So in order to do that, we subtract an x, this x here from this side, and what we do to one side of the equation, we have to do to the other. Okay, so these x's cancel, and you're left with y is equal to 6 minus x. Now, the form that we want this in is mx plus b. So you just have to look at this. Y is equal to, well, here's the x. It's a negative x. So it's a negative x. And then b, is there a sign out in front of the 6? No. That means it's positive. Plus 6. Now that we have it in this form, now we can go through and say, what is the slope and the y-intercept? Well, m is equal to what? Well, it's equal to negative. Negative what? What is this number sitting out here in front of this x that we don't see? It's -1. We don't write -1x, we just write -x, but the 1 is there. And in this case, the 1 has to be pulled out by himself. So the slope here is -1. The y-intercept, which is the b, is equal to what? It's equal to 6. So, same story. This is the slope, and this is the y-intercept. Let's do another example. Let's do example 3 on page 496. And this is going to be an example of graphing using the slope-intercept form. Okay? Graphing using the slope-intercept form. Alright, and it says, graph this equation using the slope and the y-intercept. Alright, so here's the equation. Y is equal to -3/2 x minus 1. And you're looking at that going, how do I graph this? Get a table of values going. Yes, you could do that. Back in the day when you were doing functions, you could do that. But we're not doing that this time. Now remember when we gave that table of interpreting the coordinate plane, so if things were moving up, then that was positive. Things were moving down, that was negative. Moving to the right, that was positive. Moving to the left, that was negative. That's going to help you here a little bit too. Okay? You'll notice first thing here that this is in the same form as y is equal to mx plus b. That's important because if it were not in that form, just like the last example, you would have to do whatever you needed to do to massage this and get it into that form. But now that it's already in this form, we can directly pull out values. So the m then is equal to what? It's equal to negative 3/2. The b is equal to what? Negative 1. Now what we need to do is, this was step 1. Step 2, we need to graph the y-intercept. Okay? Graph the y-intercept. In this case, b is equal to negative 1. So we go over here to our handy-dandy coordinate system. This is the y-axis. This is the x-axis. So b is equal to negative 1. Well, we said that b was the y-intercept. That means that this is where this line crosses the y-axis. It crosses it at negative 1. Right there. Alright, so far so good. So we did. We took step 2 and we graphed the y-intercept. B is equal to negative 1. Now step 3 comes along. We're going to use the slope being negative 3/2. And we're going to use that to locate a second point. Negative 3/2, slope is rise over run. Rise is up and down the y-axis, and run is along the x-axis, okay? This is y-axis. So if we have a negative 3, what does that tell us? Does negative go up or go down? Negative goes down. So negative 3 down. Here's the run. This is the x-axis. Okay? And there's a 2. So 2 is positive. That means that we go 2. Do we go to the right or to the left? Well, to the left is negative on the x-axis. To the right is positive. So we go 2 to the right. So we're going to go over here and we're going to say, here is the point. Now from this point, we're going to go 3 down. Okay, so here's 1, 2, 3. There's 3 down. Now we're going to go 2 to the right. 1, 2. So there is our second point. Now if we had enough space, we could do this again. We could go from this point, we could go 3 down. 1, 2, 3, and then we could go over 2, 1, 2, and have a third point right there. It's not on the graph, but you get the idea. So now what we're going to do is we're going to draw a line starting here, and we'll connect it down past this guy right here, and that's the line. Step 4, which was draw a line through your 2 points. Okay, now I'll make a point, no pun intended, right now. Drawing a graph, drawing a line with 2 points is good. Drawing a line with 3 points is much more accurate. Okay, this was example 3. Let's do a final problem, but there's going to be 3 parts to this problem. It's all going to be the same problem. This is going to be example 4, and they're all going to be on page 496. Alright, so the problem says that the student council is selling these Spirit t-shirts during Spirit Week, and it costs $20 for the design and then $5 to print each shirt. So there's a total cost Y to print an X number of shirts, and that's given by this equation. Y is equal to 5x plus 20. Okay, so Y is equal to the total cost, how much it's going to cost overall, and X is how many shirts you want printed. It's the number of t-shirts. So example 4 says, graph the equation to find the number of shirts that can be printed for $50. So for $50, the line equation says this. It says Y is equal to 5x plus 20. Well, we recognize that this is already now in slope-intercept form. Y is equal to mx plus b. So we do the same things now. M is equal to what? M is equal to 5. B is equal to what? B is equal to 20. So now what we have to do is come over here, And the first thing we do when we plot this, remember, is we plot B. So we come up here and there's 20, so there's B. Okay? Now how do we find the second point to plot? Well, we look at our slope. 5 here is equal to 5 over 1. So it's a rise of 5 and a run of 1. So here it's a rise of 5. We go up 5 and we go over 1. And we go up 5 and we go over 1. And then we go up 5 and over 1. We go up 5 and over 1. And we go up 5 and over 1. And then we go up 5 and we go over 1 right there. So let's draw a line. So our equation now, our problem says how many shirts can be printed for $50. Well, we look up the side here and we find out where's 50. Okay, well, there's 50 right there. So we go along 50 until we get to an intersection, and we look down and there's the number of shirts. So for $50 we go along the $50 line until we get to there, and then from there we go down, and there we have it. Over here for $50 we can print 6 shirts. Alright, so for the next piece we're going to do example 5, again on page 496. Example 5 says, describe what the slope and the y-intercept mean, what they represent. Okay. Well, let's look at this. The slope of 5, what does that mean? What it represents is the cost in dollars per t-shirt. The cost in dollars per t-shirt. So we look over here at our graph and these are t-shirts, and up here is cost dollars. So for each t-shirt, if you have 0 t-shirts, it's going to cost $20. That's the setup fee for the logo. Then for the first shirt, it's $25. For the second shirt, it's $30. For the third shirt, it's $35. So for each of these t-shirts, the price increases by $5. That's what the slope means. The slope is 5. That means that that's the cost in dollars per t-shirt. Okay, well, what's the y-intercept mean then? Okay, a y-intercept of 20. What does that mean? That means that this is the one-time, it's a one-time charge for setting up to print the logo on the shirts. Because once the logo is set up, then you can run all these shirts through there, but it takes a bit of time and effort to get the logo set up to do that in the first place, and that's what the $20 charge is. Okay, now another question here that they don't ask in the book, but why does it stop at x equals 0? Why doesn't this line continue on down this way? Okay, why doesn't it go into negative x land? Well, it doesn't go into negative x because you can't buy a negative number of t-shirts. This is a real life problem. The lowest you can buy is 0. That's why the line starts at x equals 0 and goes off to the right. Does that make sense? The last one we're going to do here is example 6. It's again on page 496. And this says, is the total cost proportional to the number of t-shirts? Okay, so is total cost proportional to the number of t-shirts. Okay, remember back in the beginning of this when I was talking about proportionality and things like that? Well, this is part of what we're talking about there. Do you remember how to determine if something is a proportional relationship? You know how to do a proportion. I mean, the ratios are equal, are equivalent, okay? But how about for a graph and a line? Well, in order to determine if this is a proportional relationship, you have to compare the total cost to the number of t-shirts for 2 points. For 2 points, we compare the total cost to the number of t's. And by comparing, we just do it. So obviously we can't do 0, right? Because that would be 20 over 0, and you get the picture. Big smoking hole in the city, divide by 0, badness, etc. So no dividing by 0. How about when x is equal to 1? So for x equal 1, we have a total cost of what? If we look up there, it's 25 over 1. And that's equal to 25, right? Now what happens when we say x is equal to, say, 6? Well, we know that one. When x is equal to 6, the total cost is 50 over 6, which is about $8.33 per t-shirt, whereas this one over here, if you just do buy 1 t-shirt, it's going to cost you 25 bucks. But if you buy 6 of them, it's going to cost you $8.33. Since these ratios are different, this is not proportional. So the total cost is not proportional to the number of t-shirts that you buy. The last point that I want to go over really quickly is this. Parallel and perpendicular lines. And I'm just going to go over this as a statement. If you had a graph like this, okay? Parallel lines. They're lines that don't touch, okay? They never intersect. So assume these are 2 parallel lines. If you look at these, what is similar to these lines between them? What's similar between these 2 lines, the top one and the bottom one? What's similar is they have the same slope. They both have the same slope. What's different about them? They have different y-intercepts. So they have the same slope, different y-intercepts. Over here, alright, if you had a line like this, pardon me, that needs to be straight. Perpendicular lines. We'll get into this later, but I wanted to put this out there so that you knew that there was a relationship. A perpendicular line, I'm going to write this in red to make sure that it stands out. Perpendicular line means that it intersects this line at a right angle. Okay? So, here's your first line, and now here's your perpendicular line. So what does that mean? What's different about them? The 2 lines have slopes that are negative reciprocals of each other. M1, the slope of line 1 is the slope of line 1. The slope of line 2 is negative the reciprocal of slope of line 1. Like I said, I just want that out there You guys know what reciprocals are. You know what negatives are. So this isn't, you know, totally beyond your ability to understand. But this is perpendicular line, this is parallel lines, and that's how slopes and y-intercepts pertain to these two. Thank you very much for listening. If you want, like the video, send me an email that you've watched this video, please, and I will see you next time. Thank you.